In this series of videos, I will perform activities meant to demonstrate some of the named thermodynamic processes. In this video, I will illustrate isobaric expansion and isobaric contraction processes between different thermal reservoirs. I will try to limit commentaries. Please watch the video carefully and pause where needed. With some exception of freeze frames, like right now, the video is unedited. At the beginning of each video, I will go through an initialization step meant to set the n, that is the number of molecules in the heat engine apparatus, at a consistent value. In this initialization, I am setting the gas temperature at about 40 degrees C with no additional mass on the piston, at the largest volume position of the piston. This gives us the largest N that will ensure that the piston won't max out in the space of available volume for expansion in the course of measurement. So we will start with the isobaric contraction from the warm water to room temperature with no additional mass on the piston. Only the atmospheric pressure and the weight of the piston provides the pressure for the gas in heat engine apparatus. Notice the change in volume due to isobaric contraction. Now, isobaric expansion from 20 degrees C back up to 40 degrees C. For the next process, we'll place 200 grams on the piston for additional pressure. And we will observe isobaric contraction from 40 degrees C down to 20 degrees C. And isobaric expansion from 20 degrees C up to 40 degrees C. We place additional 200 grams for a total of 400 grams, providing additional pressure for heat engine apparatus. Isobaric contraction to room temperature. And isobaric expansion back up to 40 degrees C. Notice with both masses removed that the piston doesn't quite return to the original position. That's because the leakage of the gas through the measurement process. For the second half of the video here, we will reset the N again at the largest volume position of the piston with the gas at 40 degrees C with no additional mass on the piston. This will hopefully give a more consistent N between the first half of this video and the second half of the video, where you will look at isobaric processes between room temperature and ice cold water. So we let the gas cool down to room temperature, and that'll give us the starting volume. The gas will undergo isobaric contraction from 20 degrees C to 0 degrees C. Note the change in volume. And isobaric expansion back up to 20 degrees C. We place additional 200 grams on the piston for isobaric process at slightly higher pressure. Isobaric contraction. And isobaric expansion. Additional 200 gram mass for a total of 400 grams on the piston, providing additional pressure above atmospheric pressure and the pressure due to weight of the piston itself. Isobaric contraction. And now isobaric expansion. So this is another trial of isobaric processes between room temperature water and warm water, and also with ice water. We also have another trial of isobaric processes with a smaller value of n determined at the initialization step. Thank you.